Yeah, we move on to really the things we want to do to try and promote good practice. And there's just a couple of pictures here of where some of those important considerations have been taken into account. And so we're going to go through the really the same process that the good practice document does. We're going to cover specification first of all, then move through to installation, and then look at aftercare and show how this all kind of joins together basically. So we're going to take you on that journey now. And it does start with a specification. Now, we could go into a lot of detail about thermal performance. Obviously, the conductivity of the product, the lower it is, so the lower the number, the better. You want the least conductive material, clearly, to insulate your pipe work. We could talk about reaction to fire and things like that as well. But actually, what I really, really want to focus on is that there are many different types of insulation products there, and they all have their unique sort of performance criteria, and they have strengths and weaknesses depending on the application. What I really want to focus on is what is good for which application around heat pumps. And when we look at polyethylene, certainly for externally located applications like the main run from the heat pump, polyethylene can be a good material as long as it's UV protected and weather protected and so on. But it's a domestic product. It's not really suitable for a number of reasons around commercial and industrial applications. Nitrile rubber, again, is a flexible foam product. So the first two are more flexible in their use, has quite a large range of applications. So is often used domestically, but can in certain applications be used in a lot of commercial and industrial type of scenarios as well. And then you have your mineral fibers and you have your phenolic foams. So all of these will be the right product for the right application, depending on the application, effectively. So we're not here to say that one is better than the other. We're here to say that think carefully about which product you're using. And when we look at how this is all laid out, I'm not going to spend too long on standards today, but just a couple of things to really emphasise that there are two key standards for thermal insulation. You have the one for the specification of the materials, so that considers the thermal performance and sets out tables so that you know the thickness of material you might need for a different application and so on. And that does help to help you to meet with the building regulations. So Part L, conservation of fuel and power, is then reflected. There's a means of achieving that through the approved documents, of course. So you have approved document L, both for dwellings, which is volume 1, and then non-dwellings, which is volume 2. They refer through to BS 5422. So all the tables in there are what really helps you to comply with what is necessary. I don't want people to worry about that too much, other than to say that the good practice guide we have launched, all the appendices help you with that. So we've done the shorthand there and the hard work so you can meet that criteria. But this is a background to what you are achieving with that. And there's also the code of practice for the installation of the thermal insulation that is currently being reviewed. That standard BS 5970. And if anybody's interested, contact me afterwards, because that will be going out to public consultation in the next 2 to 3 weeks. Okay, so that's just a general idea of the background with this and how we're helping you to comply with the standards with this document. And really just a very quick overview. We are talking again with different products. We're also talking the different tables that need to be complied with within the standards. So domestic, there is a section within BS 5422 looking at domestic services. You've got your base thicknesses or your enhanced thicknesses. But either way, they're in that section 9, and there's an appendices or an appendix within this document that explains how that can be met. And then we have your communal heat pumps. So anything effectively where there's more than one billing address, two or more billing addresses fed from the same heat source. So the heat pump, for example, they may be first of all they'll be subject to a separate section within BS 5422, but may also be covered under the heat network standards, of which we've got the code of practice CP1. Something really important to just lay out with that as well is that following the Energy Security Act, and the development of HENTAS, which is a heat network technical assurance scheme, CP1 will be replaced by a new technical standard. There's going to be some changes in that. I'm not going to dwell on that too long, but what I would say is, again, if anybody wants further information on that, to contact me afterwards, please. And then we also have the commercial heat pump application for hotels and leisure centres and things like that. Again, that's back to your section 8 of that BS 5422 standard. And the way that we need to consider the performance of the insulation isn't just dependent on the insulation itself, but it's also dependent. And bearing in mind, we're talking externally located products here. We're talking about the emissivity of the actual cladding material as well. So that's a really important aspect of it. So the higher the emissivity, the more kind of giving the product, the insulation will be in terms of heat transfer. So you have to size up the insulation to negate that issue. So again, all of the tables within this best practice guide take into account the surface emissivity. And so what we have is just a couple of examples to show you how we've done this, because the way that BS 5422 lays things out is it gives you a maximum either heat gain for below ambient or heat loss for above ambient. It gives you a maximum watts per meter scenario that you need to meet and to actually be within. So you can see here, for example, for a 50 mil nominal bore pipe, the maximum heat loss you can have is 12.61. This is on the commercial, so this is taking a commercial heat pump scenario into account. So we're looking at this with mineral fibre as an example, and because everything moves up in increments, so you don't get like a 31 or 32 mil thick insulation. You move up in 5 mil increments. Actually, what you're doing is you're moving up there to a 35 mil mineral fibre. That is beating the maximum scenario by a certain percentage. So actually, you're improving the watts per meter heat loss. You're not just meeting those standards. You're always just coming in underneath and improving that a little bit. So these tables give you that real world scenario as to what it would be. There's still a case for getting manufacturer specific calculations, but this shows you what can be done, and it's a most practical guide you can have for this specific application. So there might be more questions about that later, but I just want to show you this. This is about a low emissivity cladding, like you see on the right there, like an aluminium cladding, for example. If we move on to the next one with the high emissivity, you can actually see that to meet the same standards in terms of watts per meter heat loss, you're moving up. So, for example, 50 mil nominal bore, instead of a 35 mil insulation, you need to move up to 40. But all of this is calculated within these tables. So again, just refer to those, use that as your specification link and show that to the installer, and everybody's on the same page and it works.